Okay, hello everyone. Now we're gonna show how to design a low pass filter. Okay, so let's see how it does. First, you have to select an order from maximally flat low pass filter prototypes, and we use 9 order because it provides shorter bandwidth and more accurate to predict cutoff frequency. So we need to use this one because it's more like effective to use to create our filter. Okay, next step, we have to calculate the angle from this formula, and we have two different formula to use. For the capacitor we need to use this formula, but for the inductor we have to use another one. But after we calculate completely, the units of the answer will be radian units, so we have to convert it into degree units. So then after we have the angle, we have to assume the value of the capacitor inductor. We have to use 20 ohms and 100 ohms respectively, and then we have to use this value because it's a value that the maker needs to use for it. And that's it all. That's nothing else. So the next one, according to the picture, this is a path program, and if you see that this is when it starts. After that we input our value. If you see 20 ohms, 100 ohms, 20 ohms, 100 ohms, and we have a different angle. After we insert all of the value that we need, they will show the program will calculate and show the answer of the length and the width. After that we observe it and note the length and the width of each capacitor and inductor. So next step, we open Sonnet, and then we create new project, new geometry. Accordingly, you see the program open here. After that, we set up it, we change the analysis into linear frequency sweep. We need start at 0.1 gigahertz and stop at 6 gigahertz. Have 0.1 steps gigahertz. After that we change the units. If the units are in millimeters, you don't have to change anything, but if it's not, you have to change. And the frequency in gigahertz at all, as you've seen in the slides. Okay, next. The cell size have to be 0.05 at x and y, and the box size will be calculated by the program automatically. And we have to change the color of the top metal into free space, and the bottom metal have to be the copper. So it's like we use the copper to create our low pass filter. And then the next one is you have to change the dielectric layer. The top one have to be the thickness 20. It's air, and the properties of the air will be shown at here. Also at the ground it will be 1.6 for the thickness. It will represent as a FR4. The properties will be here. You can find FR4 in the kind of dielectric layer. You can search it in the library. If you see, you can see it. You can click it on. So after that we create a box according to the value of length and width. It's like when we create the box here, 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 and here, and you have to have two port over here. Before you putting the port, you cannot put the port over here. You have to create the box first as an input box and an output box, and this all here you can insert the value of length and width in step how can I say uh, that you can put it in there. Okay, for the next step is the last step. You check the graph. The frequency have to be near 2.4 gigahertz. It's what our teacher say that, and that's it. How to make our low pass filter. Okay, that's all for today. So thank you very much for listening to me, and see you next time. Thank you.